Hi guys, now you can see a drawing there. This drawing has got a lot of information here. You can see the three-phase induction transformer there, the delta side, the star side. Actually, most cases I've had this question. I've had this question from so many people. You find that the three-phase transformer is supplied by 3 cables only, but eventually we get 4 cables out of it, the three-phase and the neutral, and even the earth cable. Yeah? So you can see you have the three-phase there, 11 kV feeding into the delta side. Then from the star side we have the three phases and the neutral, and it is from the same neutral point that we get our earth. And in this case, that's why we understand that the neutral and the earth have got the same potential difference. It's only that the earth cable has to be grounded through the earth electrodes. Yeah. Then there we attain our three-phase, red, yellow, and blue, and we have our protection there, like fuses or breakers. So we go to our load here. You can see the red phase through a certain protection there, a fuse or a breaker, and the neutral. Then we have our load here. It might be a cooker or something, or an iron box, which also has got metallic covering. You can see the load body, metallic covering. And that's our load, which is also a resistance here. Okay, we have this guy standing here. And he's also standing on the ground. So how does an earth cable protect an individual from electric shock? An earth cable is very, very important. It's only that so many people ignore it. They don't know that is there for their own protection. So suppose between the live part here, and so this is the live part side and this is the neutral side. Suppose this live part side just comes into contact. It comes into contact with the body. We expect the metallic part, this body, to be live. And this guy is touching here. So what will happen? The earth cable, the man body, he has to pass to the ground, and actually he might connect the ground in parallel. So you expect the voltage to go through the two legs. So in case this cable is not here, the supply from the body part, it will go into this man, through this leg, and this leg into the ground here, back to the transformer, back again, and this man will be there as a load, and he'll be roasted alive there slowly. That's why you find that somebody cannot release himself from what he's touching. That has happened to me sometimes back. Yeah, you find that you are almost dying, but you cannot release your hand from where you're touching. That one happened to me. So in case we have an earth cable, this earth part will either take this route or the man's route. Now it will depend on the resistance of the cable. Definitely is lower than the resistance of the body. So and that the current flow will tend to take this path. So instead of taking through the path of the man, the body, it will take through this path into the ground, coming, and because there's more current here, because there's no resistance here. Our load is the one which limits the current flow, but because here there's no resistance, it's almost zero resistance. So our breaker from this side or next to to the load will trip, or it is the fuse we expect it to burn. Yeah. And how does an ELCB work? Because our earth cable, you can see how it is protecting us. But here we have the ELCB, and we don't have any earth connection. We don't have any earth connection. We have only the 3-phase and the neutral. So our ELCB, you can see we have ELCB here, which is 40 amps, 30 milliamps. 30 milliamps is more sensitive. Then we go to 40 amps, 100 milliamps, less sensitive. And we have also 300 milliamps. So we have several protection. So this one, the ELCB, will protect where we expect our, like this one is up to 40 amps. Suppose we exceed 40 amps, we are going from 60, maybe 100 amps. We find, we have also ELCB 100 amps, but if we go beyond that, what do we do? In that case, that's where our CBCT comes in. Core balance current transformer, CBCT, which is connected through the ELR and the breaker. Yeah, I don't have them here. I could have done a demonstration, but I don't have them here. We have also this ELCB here. You can see it is 40 amps, 0.030 amps, which is also 30 milliamps, because if you multiply that one by 1,000, what do we attain? We shall attain 30. Yeah. So in this case, we have seen how our earth cable here will protect an individual. But here, in this case, how does it protect an individual? The ELCB. The ELCB, like in this case, we expect our current flow through here, back into the neutral. Let me do that connection, then we see. So we can see our ELCB here is connected. The load is connected through the ELCB. Yeah. So we expect it to run. Okay. It's live through the ELCB and the neutral through the ELCB to the load. Yeah. So what about in case the path, the circuit path is not through the ELCB? The ELCB will detect that there is a current flow which is complete in one side, but it is not complete in the other side. In that case, yeah, maybe it will trip in that case. Let me show. In this case, our current path is only the phase, and then it we have taken from here, so we shall expect it to trip. Yeah, it will trip because the current path is not complete through the ELCB. And here we have